So good morning, everyone, and welcome to our Sunday morning panel on prosody. I'm really glad you're able to join us. We have 3 papers in our session this morning, and we are first going to hear from Guilherme de Garcia from Ball State University, who will be speaking to us on binary rhythm and syllable weight in Portuguese. Okay, so Guilherme?
Hi, my talk was actually pre-recorded. I don't know if you have the file there.
I don't.
Because I just contacted Blake and she confirmed it.
Okay. Blake, have you got...
She's in this room.
Well, just give me a second. I can play it. I didn't know that we were doing that.
By going back to finish. So we know that secondary stress is typically not affected by weight, typologically speaking, of course. But then we have finish, right? And finish is kind of a very rich language to provide interesting examples across the board. In this particular case, we're looking at secondary stress here. Primary stress is always word initial in the language, but secondary stress can be affected by weight. We also have examples like that for English even, right? Basically, light syllables here in this language are skipped if they are followed by a heavy syllable. And this is going back all the way to the 60s, for example. So we have a couple of words here to show you what I mean from Finnish. So we have the skipping of a light syllable in this position here in blue on the screen right now, in case you have a heavy syllable following that syllable. So for the word meaning we are fishing here, we skip the te syllable here and we stress, secondarily stress lam. We also have no skipping, even though there is a heavy syllable. So this is kind of countering the first 2 examples there. And we do have skipping sometimes, even though we do not have a following heavy syllable. So you can see this is not as categorical as it seems. And we also have variation, right? So we have the word for professor here. We can have either secondary stress on so in the second word here, in the second variation of the word, or in ris for the first one. Now, there are roles here being played by sonority, both sonority and clash avoidance. And this brings back to the discussion the whole debate on lexical versus post-lexical planes. It's usually assumed that secondary stress is more concentrated on a post-lexical level. It's more predictable. It doesn't have to be marked at all, etc., etc. But of course, if there are lexical components that are affecting secondary stress, this indicates or at least suggests that there must be some sort of communication between these 2 planes. And this is in a way what I want to focus on today. So let's bring the discussion back to Portuguese now. Now, primary stress in Portuguese respects a trisyllabic domain at the right edge of the word. It is affected by weight, so it's a weight-sensitive language. And we could summarize regular stress very easily with 2 lines of the frame here. First, we have final stress whenever we have a final syllable that happens to be heavy. So that's a very, very robust pattern in the language. And we have a couple of examples here on the screen.
Okay, so since we've got some problems with misalignment with the files, we're actually going to hear from Guilherme live. So
Yeah, let's just do this live because it's definitely not working properly, and I'll just skip a couple of slides here. Let me share my screen quickly. The beauty of technology. All right, can everyone see my slides here?
Yes.
All right. So we all already know the title of the talk. And the example I gave from Finnish to begin with was to kind of go back to this very famous case where secondary stress can be affected by weight. Typically, primary stress is famously affected by weight in many languages. English, for example, and Portuguese is no different. In fact, English and Portuguese are strikingly similar once you look beyond the surface. So Finnish is an example where primary stress is fixed. It's always word initial, but secondary stress happens to be affected by weight. And we can see that because light syllables are skipped by secondary stress when they're followed by a heavy syllable. So you can see here on this slide, a couple of examples. You have the word for you were fishing, where you have initial primary stress, it's fixed, and then you have secondary stress skipping a syllable. But then when you have this heavy syllable here in B, you skip the te syllable, which is light, because there's a heavy one coming up next. However, we also have situations where there is no skipping, even though there is a heavy syllable there in red here. So you don't skip the blue syllable here. And we also have skipping, even though there is no following heavy syllable, right? So clearly it's not a categorical exceptionless pattern. And on top of all that, we also have variation in secondary stress. We can see that with the word for professor here. We can have secondary stress on risk, but we can also have secondary stress on so. So we have variation there. There are roles here being played by sonority and clash avoidance. But the reason why I'm bringing this up here is because it takes us to that old discussion on lexical versus post-lexical levels or planes or dimensions. And clearly, if there are lexical aspects or components being influencing secondary stress, which is presumably more post-lexical than primary stress, there must be some sort of interaction between these planes. And this brings us to Portuguese. So that's why I wanted to kind of talk about Finnish there. Portuguese is a trisyllabic domain for stress at the right edge of the word, and primary stress, unlike in Finnish, is not fixed. So it actually moves around within that trisyllabic window. Now, regular stress can be very easily generalized with these two lines on the slide right here. If the final syllable is heavy, final stress. If not, then penultimate stress, and you have some examples there. We also have, of course, irregular stress patterns or subpatterns. And those can be summarized with three subpatterns. I'm simplifying here, but you can always go back to these three. The first one is if you have final stress and there's a light syllable there, or penultimate stress if there's a heavy syllable word finally. That's the second line here. And finally, any words that happen to have antepenultimate stress will be considered to be irregular, unpredictable, et cetera, even though they are not 100% unpredictable, it turns out. But anyway, so that's primary stress in the language, and primary stress in Portuguese is weight sensitive. Secondary stress, on the other hand, is supposed to be insensitive to weight. And I mean, that's according to previous studies. Basically, you stress every other pretonic syllable from right to left, and you're fine, right? So here are three examples: international, butterfly, and block paving, where you have final, penultimate, and antepenultimate stress, and you can see secondary stress is basically going from the right to the left, skipping a syllable. So it's just stress every other syllable, and you're fine. However, we do have variation, just like in Finnish, we have some variation in secondary stress every time we have an odd number of pretonic syllables in the language. So we have the words here for cacophony and improvement, where you have penultimate stress in both, right? And we have an odd number of syllables before that syllable. And so what happens is we can have initial or peninitial secondary stress in these words here, basically. The answer, of course, the question that I'm asking here is, could weight also affect secondary stress in Portuguese once we basically target a scenario or a context where variation is allowed, right? So that's really the main question that I want to answer, a specific question, then I'll go back to the lexical versus post-lexical planes that I mentioned before. Now, to look into that, I developed an auditory judgment task. It's a forced choice task using Prod here, using nonce words in Portuguese and testing native speakers of Brazilian Portuguese in this case. But stress in Brazilian and European Portuguese is fairly similar. There are important differences between the two varieties, but stress is not one of them, directly speaking. And so the stimuli are divided in two groups. And so let me just go over the 4 syllable stimuli, because these are the controls, right? And they're the controls because you don't really have, you don't really expect variation here, right? You basically have a light, light, heavy, light word, for example. This is the reference level for the controls, where the penultimate syllable is heavy. And so here you only expect secondary stress to be initial, because pen-initial secondary stress in these words will result in a stress clash, right? And that's, of course, not ideal. We don't really have that being a productive scenario in Brazilian Portuguese. And so that's why these are the controls, because here it's almost like a sanity check. You want to make sure that people do go for primary initial secondary stress rather than pen-initial secondary stress, just to make sure that the experiment is working the way it should. The interesting group, of course, is the 5 syllable stimuli here, where you have light, 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 pretonically, for example, where you have the rectangle here, or H light, light, or LHL, or light, heavy, light, right? So you have 3 possible combinations of weight, pretonic weight here. So basically, the reference level is the level where we have no weight at all pretonically, so all light syllables. But then, of course, we have a heavy initial syllable and a light initial syllable versus heavy pen initial syllable, just to see, can secondary stress preferences be in a way affected by this heavy syllable position here. And so these were all minimal pairs, same word, initial and pen initial secondary stress for both of them. That's how they were recorded. And here you have a couple of examples. So you have a word like argadoriste versus argadoriste, right? So that's just to give you one example of the target words that were used in the experiment. Important to mention here is, it is important to notice that duration is the main correlate for primary stress in Portuguese. This is something that has been confirmed in several studies, first in the mid-80s with a study by Major there, but also several other studies since then. Duration is a very, very strong correlate, but secondary stress is a little trickier, right? First, it's harder to capture. Most studies point to duration, but there are also some studies pointing to intensity. It's not that different from what you get in Spanish, for example, which is a similar language in terms of stress patterns, but it happens to be a little trickier to capture secondary stress too, right? So basically, let's assume for now it's duration, and we'll talk about that in a second a little more. Let me give you a profile for the stimuli. Now, just to remember, this is not a production experiment. It's a forced choice task, right? But these are the stimuli. So this is actually the durational profile for each syllable in the stimuli used in the judgment task. So you can see here, we're looking at 4 syllable words. So these are the controls, right? When we have initial secondary stress, you can see the syllable number 1 here, which is the first syllable in the word, is longer than the second. And the third is the longest. Of course, that's where primary stress is, the second to last syllable. So you can see there's a very nice alternating rhythmic pattern on the left-hand side here. But if you look at the right-hand side, this is where you have a clash, right? Because you have pen initial secondary stress, and it's a 4-syllable word with penultimate primary stress. So you can see there's a durational clash, so to speak, because you go up in duration from syllable 1 to syllable 2, and then from syllable 2 to syllable 3, you go up again because that's primary stress. So these were recorded by a native speaker with phonetic training and then adjusted accordingly using Prod. But of course, some noise was added to the stimuli because basically, otherwise the stimuli could sound too artificial, right? So these are as natural as I could make them, basically. If you look at the 5-syllable word group, which is the target group of stimuli here, you can see a nice durational pattern where if you have initial secondary stress, the initial syllable again is longer, right? Then the second and then the third, there's a dip in duration here. And then of course you go up again for primary stress. And you have, again, an alternating rhythmic pattern for the pen initial situation. So just to basically show you how in the stimuli, the notion of secondary stress was encoded. And so this can kind of confirm most studies that point to duration as a robust correlate to secondary stress, even though it's a little tricky to converge on one particular correlate there. So let's look at the main results here. We can see on the left-hand side, we have 4 syllable words. These are the controls. Overwhelmingly, participants prefer initial stress over 75% of the time. This makes perfect sense because the alternative results in a stress clash, right? So this is just, again, the sanity check I mentioned before. If you look at the 5 syllable words, you can see everyone is kind of clustered around the 50% mark, which is good because this is exactly the variation that we observe in the language, right? Now let's focus on the blue and orange bars first. So the blue bar here is basically saying that, people prefer initial secondary stress if there's a heavy syllable there versus in pen initial position, right? So basically go up and down. Notice though that even when you have a pen initial heavy syllable, you're still preferring initial secondary stress more than 50% of the time. So there's clearly a bias towards initial stress, but this bias seems to be modulated by the presence of a heavy syllable when you look at these 2 groups of words. Now you may be wondering, why is it that the white bar is so high, right? I mean, it's just better than everything else that we see in this group, meaning participants actually prefer initial stress the most when there's no heavy syllable at all pretonically, right? And so I will talk about that in a second. For now, I just want to focus on this difference because here weight is kind of controlled for, and you see what I mean in a second. These are just the statistical results confirming the figure I just showed you. So these are the posterior distributions for all 3 weight profiles. If it's, if you see here a distribution that's positive looking at the x-axis, it indicates preference for initial secondary stress. So if we don't have any heavy syllable pretonically, you can see the posterior distribution is entirely positive, which means they really, really like initial secondary stress in those cases. And then of course, the other 2 weight profiles are negative relative to the first one, meaning they prefer initial secondary stress less often when you include a heavy syllable pretonically. But of course, the weight effect that I'm interested in is connected to the difference between HL and LH word initially. And here you can confirm the effect I mentioned before, the 50% maximum density, the interval here that you can see, the 95% highest density interval over here, and the 50%, so that's the dotted line, and the solid line represents the 50% highest density interval in the posterior distribution. You can see they overlap a little, but clearly, there's statistical credibility to the claim that there's a weight effect pretonically in secondary stress here. Now, of course, all the results, as I said, have to be interpreted relative to the intercept, which is the light word here. And the little circles just represent the offset for the slope, the by ID or by speaker slope for weight that you see in the model specification at the top of the screen here. Now, just a small detour here, very brief. If you look at the reaction time of the participants, you also see really, really fast in the figure. When you compare that with the 5 syllable words, which are the target stimuli, they're still faster picking initial stress, again, confirming the bias I mentioned before. But they are much less fast compared to the situation where the alternative results in a clash. So this is just something to bear in mind. And there's also some trends of coda effects that I can go over. They may be, because there's a trend that seems to be increasing in that direction. So to summarize, there's an overall bias towards initial secondary stress, and the stronger bias is found for 4 syllable words. No surprises there, clash avoidance, of course. But the location of a heavy syllable seems to affect their judgments in the sense that they prefer initial secondary stress when there's a heavy initial syllable rather than when there's a heavy pen initial syllable, which kind of brings us back to the discussion of a phenomenon that has been considered to be post-lexical in Brazilian Portuguese is clearly being affected by a lexical factor. Now, the final thing I wanted to mention, and now, of course, I'll have to go a little over time given the issue that we had before. Oh, okay, so I just heard here that I have 5 minutes, so that's plenty of time. Great. Okay, so I wanted to mention that there's this very obvious ambiguity related to the 50% mark. So when you aggregate all the responses from participants and they happen to be clustered around 50%, it's kind of hard to say if 50% represents, you know, they're thinking both options are good, so I'm going to oscillate, versus both options are terrible, so I'm going to oscillate, right? So it's not that obvious what 50% represents. And the reason I'm mentioning this is because one potential hypothesis here for the results that we see on the screen is, you know, the presence of two heavy syllables can be seen as less natural. And so it follows that if the interpretation of the 50% mark is that both options are not so good, then if they find that having two heavy syllables is less natural and therefore not that great, you would predict the score or the responses for light, Pretonically to be a little higher. And the reason I mention that is because if you look at the Portuguese lexicon, most words have either 0 heavy syllables in them or 1 heavy syllable in them. Those stimuli happen to have 2 heavy syllables. And if you look here at this figure, words containing 2 heavy syllables in the lexicon are relatively rare compared to words containing 0 or 1. So this is a confounding factor in the stimuli, which I'll discuss, you know, in the next step of the project here. But the most important thing explaining the results and the puzzling pattern for, you know, having no heavy syllables pretonically whatsoever can be connected to the phonetics. And what I mean by that is, let's just pause for a second and consider duration, just phonetic duration. So we could basically pose the question, could duration in the stimuli be explaining what we see in the results? And maybe, and I'll show you why. If we take the initial and pen initial ratio in the item with, you know, initial stress, and we take the same ratio for items with pen initial stress, and we get the ratio of those ratios, what we see is something quite these are the results related to the ratios. Now, what happens here is the following. When we don't have a heavy syllable pretonically, the durational ratio between initial and pen initial can be augmented a lot. It can basically be emphasized. And the reason for that is kind of intuitive, I think, because if you don't have a heavy syllable, you can shorten and lengthen your syllables with no constraints. But if you have a heavy syllable, there's only so much you can shorten that syllable because it is phonologically longer. It has a coda after all. And so that basically constrains how much of a difference you can get in your durational ratio. And if you look at the figure on the right-hand side here, looking at the durational ratio of those 2 syllables, it is a mirror image of the patterns that you see in the overall results. So if it is true that participants are mostly relying on durational ratios and the durational profiles of those syllables to pick what they prefer, then this could explain what's happening when you don't have a heavy syllable. In other words, you can't really measure a phonological weight effect including a light Pretonic sequence, because that's a situation where basically you don't have weight and therefore the durational ratio can be whatever syllable you need to make salient or prominent in that situation. Now, the next steps I have here are basically to check to see if we observe the same patterns if we remove the lexical statistics from the equation here and look at only stimuli that end with LLL. So removing that 1 heavy syllable, so that should reduce the problem of the lexical statistics being basically affecting participants' opinions or judgments of the naturalness of the words. Second thing I want to look at is whether durational ratios alone can explain the difference that we see. And this is a little tricky, of course, because there's a good amount of correlation between phonological weight and phonetic duration. And then, of course, one question that I do have for when the pandemic times are over is whether, you know, production will mirror judgments. I mean, these are important questions to answer if we want to really dig a little deeper and find out why the results look the way they do. And so these are the next steps, which would have been finished at this point if we were in normal times. But so that's where I'm moving forward in the near future. Thank you very much.
Thank you so much for such a fascinating presentation. So if anybody has any questions, we've got about 4 or 5 minutes for questions right now. And you can go ahead and even just type those into the chat. So as we're waiting, oh, Bjorn has a question for you.
Hi, thanks so much for the great talk. I have a question about about the heaviness of these syllables and how that influences the pattern. So you've noticed that 2 heavy syllables might be something that is unnatural. So my first thought was, but what does it say then about the experiment or the question that you're asking, right? But later I understood that the generalization seems to be that there can only be 1 heavy syllable, but is it true? Are there many words where like the primary stress is a light syllable, but the secondary stress is a heavy syllable? Like, do you have, are there a lot of words like that in the language that have that structure?
So you're cutting off a
Oh.
Okay.
Oh.
You know what? I'll just try to write it up and post it in the chat, and maybe someone else can ask a question.
I think now it's back.
Okay.
There we
You
go.
were asking about if it's how common is it to have a primary stress on a light syllable, but secondary stress on a heavy syllable. Is that it?
Yes.
Yes, because I thought that, if you ask the question about the influence of heaviness on secondary stress, but then it turns out to be the case that people don't like those words anyway, the question is, how much would you really say about Brazilian Portuguese,
Mm-hmm. You actually have a good amount of material where secondary stress happens to fall on a heavy syllable and primary stress is on a light syllable because of certain morphological derivations that you get in the language, where you may have, say, a prefix that ends in a coda and is syllabified as a heavy syllable, and the penultimate syllable in the word happens to be light. So you do have a lot of those constructions in the language. So I think there are different possible scenarios here for why people may not like certain word shapes, but I don't think that this asymmetry, words that have multiple heavy syllables, because that is definitely something that we don't see much in the language. And so that's why I think it is definitely important to take into account this, frequency of phonotactic patterns and, even bigram probabilities in the stimuli to kind of remove this from the equation, because they may be basically disliking certain patterns for reasons that are not necessarily connected to weight itself. But again, that's one of the reasons why focusing on the stimuli that contain a heavy syllable pretonically is important, to really zoom in on any possible weight effects, because if you also include stimuli like in the control group there, where you have no heavy syllables whatsoever pretonically, then you introduce some confounding factors, and now you don't know if there's an asymmetry in their responses, if it's because of weight itself or if it's because of phonotactics or lexical statistics, etc. Yeah.
Okay, thank you.
Thank you.
All right, so we are just at the 10:29 mark at my time, or 29 wherever you are, depending on the hour. So we will say a thank you to Guilherme for a really fascinating presentation. I have to say, the visualization of stress clash was fantastic. I really like that. So yes, so thank you. And we are then ready to hear from Yuhong Ju. All right. So our next talk, like I said, is from Yuhong Ju from Ohio State University, who will be talking to us on contrastive Moraic and syllabic footing in Suzhou Chinese, pitch patterns of toned and toneless moras. So take us away.
All right, thank you. Can everybody hear me? Everybody hear me okay? This might be a little bit loud, so I'm going to turn the volume a little bit down. Okay, all right, let's get started. So I'm going to talk about Moraic and syllabic footing in Suzhou Chinese, the language I work on. Here are two main claims. First, in Suzhou Chinese, there are a group of disyllabic prosodic words of the shape light and heavy. So a light initial syllable followed by a heavy second syllable. I will argue that they are parsed with a left-aligned bimoraic trochee following Carver 1993. Hierarchically, it's a metrical foot directly dominating the first two moras, leaving the third mora unparsed. So if we look at the bottom right corner, here we have a prosodic word, a foot, three moras, directly parsed, the first two directly parsed by the foot, and the syllable boundary is marked by a dot. You can think of it as a somewhat weird 3D projection, right? So the syllable doesn't necessarily intervene between the foot and the mora. A consequence of this is it leaves the third mora being unparsed by the foot. Consequently, we are essentially looking at a quantity-sensitive footing alternation where only light-heavy disyllables are parsed by the bimoraic trochee, and all other disyllables are maximally parsed by disyllabic trochees. So we have a contrast here based on if the first syllable is light and at the same time if the second syllable is heavy. Secondly, the unparsed mora in the proposed bimoraic trochee varies in pitch when surrounded by different phonological tones in different prosodic domains. So they are high level between two high tones. They're falling between one preceding high and then falling low. They're rising between preceding high and then falling between a preceding low and falling high, right? Also, they are always low levels in phrase final position. This is possibly due to a low boundary tone. There's no independent evidence for phonological alternations such as tone spreading. So I believe this is better explained as phonetic interpolation between true tonal targets. This is reminiscent of the variable pitch realization of so-called neutral tones in Mandarin Chinese, which has been broadly studied. All right, a little bit of background. The bulk of the data I would use in this talk comes from Tongsandi, the phonological processes where morphemes of certain underlying lexical tones surface with different surface pitch, right? So a crucial observation about Northern Wu, the family I'm talking about, is called left prominence. Here, prominence is manifested as a phonological property, indicating that the leftmost morpheme has a certain tonal stability. Simply put, lexical tones belonging to the leftmost morpheme are always preserved in Tongsandi. So here's a very illustrative pair in Shanghai Wu, a very close neighbor to the language I'm going to talk about today. What is crucial here is when we have the same initial morpheme, hand, with a mid-high tone, the mid-tone and the high tone is always preserved on the surface, no matter what tone the second syllable or the second morpheme has, right? So basically, non-initial morphemes should play no role in determining Tongsandi in this family. So this is a typical case. Non-initial morphemes don't play any role. This is not entirely true in Suzhou Chinese. I made this observation from my own data. This pattern was either ignored as free variation or not discussed at all in previous documentations. So basically, second morphemes in a prosodic word can actually affect output of tone sandhi, but only when following a initial light syllable. So here's a pair in Suzhou, blackboard and black cup, with the same initial morpheme black, right? The second morpheme is either board or cup. On the surface, we have hebe with a following tone on the second syllable, or hebe with a low flat tone in the second syllable. I term this subset of words light initial sandhi as words demonstrating non-initial morpheme conditioning all have a initial light syllable. And this is going to be the focus of the current talk. What's even more interesting and what's going to be our focus today is the fact that light initial disyllables vary in phonetic pitch when in phrase non-final positions. So quickly, here's a pair black cup and a longer phrase, planing of the black cup. So planing is here in the third and fourth syllables. Originally, black cup is a low level in the second syllable, but when followed by a high tone, it changes to a low rising tone. So it goes something like 河北清洁, right? The current talk explores this pitch variation in longer prosodic phrases and compounds. Here are some previous analyses on Northern Wu and Suzhou in general. So how is tone sandhi in Chinese languages traditionally accounted for? Many people have proposed prosodically motivated accounts where they claim that tone sandhi applies basically within certain prosodic domains. Those domains could be a metrical foot, a prosodic phrase, or a minimal rhythmic unit, MRU, that ranges in size from minimally a foot to maximally in an intonational phrase. Here, what's relevant for our purpose is metrical or stressed foot. Many people have proposed that for Northern Wu Chinese, metrical foot is generally the correct sandhi domain. So the core argument of a metrical foot-based analysis is the proposal that metrical prominence may exist independent of phonetic stress. It'll give a three-way contrast between a metrical foot head, a metrical foot dependent, and a unparsed prosodic units if you have a longer word, and they all interact actively with tonal association or lack thereof. So the foot head usually preserves tones. That's the tonal stability we've been talking about. The reassociation of tones is possible from the foot head. The foot head is always able to bear a tone. The foot dependent will delete all of its tones, but it's still able to bear a tone. The unparsed prosodic unit deletes all of its tones, but it's also unable to bear a tone. So here is a quick schematic where the foot head marked with a plus retains its tone. Sometimes it spreads, sometimes it redistributes its tones. The dependent delete all of its tones, but it's able to bear some tone if permitted. The unparsed syllable or the unparsed prosodic unit is always toneless and deletes all of its tones. So the biggest criticism for such an approach is its circularity. Numerous researchers have attempted to locate stress by experimental and acoustic measures. They don't really agree with each other in their conclusions. Matthew Chen here has an excellent summary table on contradicting claims and acoustic evidence that is potentially indicative of stress in Mandarin. But the baseline is there's no easily observable phonetic stress. Foot heads do not necessarily have acoustic correlates such as duration, pitch, and intensity, as we see in English. So in the end, there has been not much agreement in what is stress and what is not. except for the widely accepted claim that grammatical particles in Chinese languages in general are usually stressless. In a compound noun, we just don't see any reliable acoustic cues. So tonal behaviors in this way becomes the only evidence for foot structure, in that footing is motivated by tone sandi or tonal behaviors, pitch patterns on the surface. And at the same time, the analyst would say tone sandi applies within foot domains, right? This is being circular. What we really need is some other independent support for the metrical foot. Ideally, it's not even tonal, right? It's going to be segmental or prosodic, such as flapping American English. So in my previous fieldwork and analysis, I will summarize my attempt to find extra support for metrical stress in Suzhou Chinese. In a few papers, I've argued that light initial sandi or tone sandi of light initial words in Suzhou Chinese presents unique challenges to the foot-based approach. And a footing alternation basically is needed, where we see this alternative choice of bimeric or disyllabic trochees based on initial syllable quantity. I presented mainly two pieces of evidence, one structural, one phonetic. It's partial. I'm going to try to complete it today. So the structural evidence is a relationship between foot head and foot dependent weight. It's being called head dependent symmetry. Simply put, it is just preferred to have a foot head that is lighter in syllable quantity than the foot dependent. Light foot head plus heavy foot dependent is cross-linguistically disfavored. And Suzhou, in this case, opts for a bimeric trochee to kind of repair the ill-formed structure. So here we see a pair of light-heavy disyllable, where the bimeric trochee wins over the disyllabic trochee, which was the default. Simply put, a heavy head plus a light dependent is okay. Head and dependent being both heavy or light is also okay, but light plus heavy is bad, and it's repaired in such a way. Some phonetic evidence. There are in total 3 types of pitch patterns in light-heavy disyllables. They are shown here: a high tone followed by a low tone, high tone followed by a falling tone, low tone followed by a high falling tone. What is crucial here is the fact that all patterns have to end in a low pitch in phrase final positions, because during this stage of elicitation, I was always eliciting words in a carrier sentence, such as say blank for me, where the blank is always disyllabic and at a prosodic phrase boundary. So the current investigation provides a little bit of a deeper dive into this phonetic evidence. So as we see phrase final, there's always going to be a low tone. It's often referred to as a default low tone, either by a underlying assumption that toneless syllables or toneless moras always assume a low pitch on the surface, or by some kind of default low tone insertion rule. So how is the same prosodic unit realized phrase non-finally? Now we're going to look at what people have proposed, what I have proposed to be toneless. Are they still low tones in phrase final, non-final positions, right? And is the surface pitch variation I just mentioned in longer words, quadrisyllabic and trisyllabic words, related to this kind of tonelessness? And is a weight-sensitive footing analysis still attainable to account for this variation? So the methods are more or less similar to what I've done before. I've only switched the elicitation items. Now I have composed a list of 83 trisyllabic and quadrisyllabic compounds with varying lexical tone combinations. They're eliciting the same carrier sentence, say blank for me, where the blank will stand for a prosodic phrase. Crucially, I will have a light initial disyllable followed by some other syllables because it's trisyllabic, quadrisyllabic, such that the light initial disyllable will not be in phrase final positions. This part of fieldwork is exploratory. Tonal combinations were not explicitly controlled. I was just trying to get as many items as possible. And in total, I've got 2 participants, age 22 and 26 and 28 at the time. Both are male. Data collection is paused due to the pandemic. Here I show pitch data of 8 compounds controlled for underlying tone and weight contrast. So here is a quadrisyllabic word I'm going to present. I'm going to direct your attention to the shady box. So the word is White Flower Park. Crucially, the box includes the second syllable and partially the third syllable of every trisyllabic and quadrisyllabic item, where the colored part is what I propose to be toneless, represented as the null sign. Right. Here, what we know from this word is that the toneless mora is a high level pitch between 2 high pitched moras. Right. So the second syllable is completely high flat. Now we have a contrast between high low and high falling. The third mora or the final mora of the second syllable now is part of a falling pitch, right? Because it's in between the high and the low tone. So when initial syllable is light, we see a variable pitch, high low pitch between 2 highs, high falling pitch between a high and a low. I transcribe the second syllable as a high tone and a toneless mora. Crucially, we don't see that kind of variation in heavy initial syllables, where we have a first and second syllable being both heavy. Right, both of the second syllables are high flat. There is no variation. Furthermore, we see a bunch of trisyllables with the same kind of pitch track. Here we observe a low rising pitch because there is a low and high in this condition. Right, so the second syllable is a low rising between low and high, but it's a low flat between 2 lows. Right. They differ only in the main verb blows or comes. That gives to the surface different surface pitch. Similarly, there is no variation here. Both are heavy. Both are a high level tone, regardless of the following syllable tone. Right. So no pitch variation. So a interim summary. Abstracting away from tonal profile, we have when you have a longer word with the form light, heavy, heavy, you have a third mora or final mora of the second syllable being toneless. Its pitch is completely determined by its surrounding phonological tones in a pretty straightforward way. Right? It has high level raising and falling. When you have a heavy initial longer words, trisyllabic or quadrisyllabic, the second syllable tone does not change. It's always going to be what it is, regardless of the flanking 2 phonological tones. So pitch variation in light initial sandhi is easily explained as phonetic interpolation effect of toneless tone varied units. It's a high flat between 2 highs, falling between high and low, rising between low and high. In a light high disyllable, the final third mora is always toneless. I think I have 1.5 minutes. I'll go pretty quickly with a metric analysis, basically a recap of what I've done before. So what we know so far, the third mora is always toneless, right, in this kind of structure. In a heavy disyllable, the final mora is always toned. So all 4 moras are toned. In a quadrisyllabic word, the tone sandhi of third, fourth syllables are unaffected by the first 2 syllables. The proposals I have is tone bearing status is determined by whether the mora is footed or parsed. So if it's unparsed, it's always toneless. In a light heavy syllable, we only parse the first two moras, leaving the third being empty or being toneless. In a heavy disyllable, we always parse everything, leaving everything being toned. And quarter-syllabic words need 2 feet. This is basically following Duanmu. Here are some trees with a light initial disyllable with a stranded or unparsed third mora. You see that parallel in 4 of these trees, whereas in a heavy disyllable, the third and fourth mora, or everything under the second syllable, is always parsed and toned. Short conclusion, this provides extra support for bimeric footing in light heavy disyllables. Also provides better empirical coverage of the acoustic data. Now we have shorter and also longer words in different tonal contexts. Toneless prosodic units interpolate between tone targets, much like neutral tones in Mandarin Chinese. And the analysis counters the assumption that default low tones documented in typological different languages are always utilized as low tones, right? They are not always low. They, in phrase non-final positions, could be a range of different tones depending on the context. Thank you.
All right. Thank you so much. What another fascinating paper. So we have, we've got about 9 minutes that that we have for questions. Would anyone like to begin the questions? And I'm seeing something pop up here. So we have a question from Samuel Anderson, and he says, or sorry, they say, thank you for the talk. Suggestion rather than a question. A footing like the first mora followed by the second mora, and then the unparsed third mora, where the first or the second and third moras are part of the same syllable, violates syllable integrity, which mandates that foot boundaries coincide with syllable boundaries. So it may be useful for you to compare the Suzhou with other languages that have been proposed to violate syllable integrity. For instance, the Mauraic foot used in the stress system of Banawa, and then he has a number of them in there. And Sammy, my apologies for the pronouns.
Thanks, Sammy, for bringing that up. I actually talked a lot about valuable syllable integrity in the longer versions of my paper. So Kafir and I think a few of his co-authors, they have been talking about that for a little while now, right? What I remember is a paper they wrote a few years ago about, I think, Tokyo Japanese long word accentuation. And also, I believe Japanese, where you count moras and you count to 3 basically. And what they have is a later foot analysis, leaving the third mora in a different plane. So that's also kind of violating syllable integrity. I think Brettler had a full dissertation about syllable integrity and this kind of violation. And I think for sure we're seeing more languages popping up that violates this principle, we would say 20 or 30 years ago.
Okay, thank you.
Jason has a comment in the comment section. Britta, do you have any plans to access tonelessness quantitatively? Yes, for sure. So as I said, this the plan was paused. I was supposed to be back in China last summer, right? It's been paused. But the first thing I'm gonna do when I'm able to travel is definitely trying to find more people, getting more controlled data. So now we only have basically 4 pairs of very carefully controlled combinations. What I'm gonna do is having more pairs and average all of them up, analyzing them in a more quantitative way. Thanks for the suggestion. And I think Nina has a
Yes.
hand up.
Yes, you beat me to it. Go for it. And Nina, as we're trying to unmute you.
Oh, she's live.
Yes, can you hear me?
Yes.
Okay, thank you, Johan. Really great talk. Could you perhaps share your slides again? I was wondering about this
All right, let me see.
towards the end where you present the metrical analysis.
Yes, I went through a little bit too quickly. Right here.
Yeah, so I was just wondering, so since this is kind of, it's something, a way of representing things that maybe, well, we aren't all very used to looking at. So I was wondering if you just could walk us or walk me through it again, sort of how, looking at the very first foot, for example, how you derive it. So like this, how do you get from the underlying foot structure of the two elements to getting at this representation, if that
Yes. So I'm going to assume foot formation precedes all of the tonal stuff, right? So before everything, we're gonna derive the foot. So in this case, we have a light, heavy quarter syllable, right? The third and fourth heavy syllables are always going to be parsed by a disyllabic foot. This is just maximal parsing, right? We don't have to worry about that. The only role it plays is providing a high tone context for the preceding disyllable, right? The light heavy disyllable is the problematic one we have here. By default, Suzhou will parse every disyllable with a disyllabic foot, the one we are familiar with. But in this case, we end up with a light head and heavy dependent, which is apparently dispreferred in the language. And what I argued in my paper was Suzhou kind of repairs this by selecting a bimoraic trochee, leaving a more unparsed and toneless. And the little dot here is actually the syllable. So, there is really a foot cutting across the second syllable.
Very cool. Thank you.
So then are you, if I'm understanding correctly, are you proposing then pretty much a hybrid sort of system where the two are existing side by side?
Yeah.
Based as well as a syllabically driven trochee?
Yeah, so if we think about the strict layer hypothesis, this is definitely breaking that, right? You have mora, foot, and syllable floating somewhere as like a 3D structure. They're not hierarchical in that regard, and I don't assume that the syllable has to follow the mora and then the foot, right? In this case, in the let me get back to the slides. Yeah, in the bimoraic trochee, it doesn't have to. The syllable is somewhere else. And I still believe there is syllabification in the language. It's just not playing any role in footing in this regard. Right. Any more questions?
All right. Any other questions? Yes, and in fact, I was just, Bjorn can even speak a little bit more to this. The reason why this is additionally fascinating, other than the difference in the syllabic boundaries, is even in some of the Germanic, like German and Dutch dialects, we often end up saying, for instance, that that we went from a more weight sensitive system to now a more syllabic system, and yet in certain aspects of the lexicon, I mean, it's not within the same word, but even within the lexicon, we see that sometimes we still draw on more of the weight-based trochees. The bulk of the language has shifted to a syllabic-based trochee. So it's kind of an interesting situation that creates an even closer tie between those two trochees, what you've got there. And in fact, Bjorn, do you want to add something to that?
Oh, I mean, not that much, right? Also in the interest of time, but indeed, I mean, while in Yuhong's case, this is like completely predictable on the basis of the heaviness of the initial syllable. In the tone accent systems, at least in some of them, it sort of has to be lexically stored. But the similarity is that there seem to be some, possibly, right? If that's the right analysis, there are some words that seem to count syllables for their foot structure, whereas other words count moras for their foot structure. Yes.
Yeah. That's very cool. Awesome. Well, thank you so much, and a round of applause in our virtual sort of way for a great paper. Thank you so much.
Thank you.
All right. And our last paper in the session is from Bertie Barron, who is from Georgetown. And she will be talking to us about Valheitis, resolution in Ikpana, multiple conditioning, and categoricality.
Thank you. So can everybody hear me?
Yes, you're coming
Great.
through.
Okay, excellent. So Valheitis is typically defined as a sequence of adjacent vowels belonging to separate syllables. And as such, it arises at various morphosyntactic boundaries. While some languages freely allow for Valheitis to surface as such, there's a wide variety of languages that actually disprefer surfacing hiatus and revert to resolution strategies. So Malay, for example, reverts to glottal stop epenthesis, while Yoruba, at least at verb-object boundaries, reverts to vowel elision. There are multiple possible outputs for underlying Valheitis, and Casali actually lists 6 possible strategies. Among those strategies, heterosyllabification and epenthesis don't require the reduction of any of the 2 vowels, while for the 4 other strategies, at least one of the 2 vowels is being reduced. There are multiple possible factors that can affect Valheitis resolution. In the phonology, both segmental and non-segmental properties can affect hiatus resolution, with properties such as vowel quality, vowel length, and tone. And there are also morphosyntactic factors that can affect Valheitis resolution. For instance, morpheme status, boundary type, or morpheme ordering can all play a part in resolving hiatus. In addition to that, syntactic and prosodic factors are also can also be active in hiatus resolution, with syntactic boundary, minimal word length requirement, or prosodic boundary type. And finally, other factors such as lexical preference, speech rate, and production planning may all come into play in variable hiatus resolution. So the case I'm discussing here today is the case of Valheitis at word boundaries in Ikpana. Valheitis in Ikpana is highly common underlyingly at word boundaries, and it is, as observed, variably resolved. There are multiple resolution strategies that are available in the language, and hypothetically, both syntactic and phonological factors affect hiatus resolution. So as such, Valheitis at word boundaries in Ikpana forms a case of potentially multiply conditioned and also non-categorical phonological alternation that is worth investigating. So here's an overview for this talk. So I'll be providing some background information on the language, and then I'll be discussing 2 separate studies and providing a theoretical account for both of them. So Ikpana is a Kwa language spoken at the border between Togo and Ghana, and it has approximately 7,000 speakers left. It is endangered and underdocumented, and more particularly, its phonology and prosody have been largely described. There's also an attested increase in loan words and syntactic changes that are mainly influenced from Ewe, which is the majority language in the area. As far as its phonology and morphology, Ikbana counts 7 phonemic vowels with ATR contrasts for mid-vowels only. It also counts 3 phonological tones, and only glides and nasals are possible codas in the language, but those are rarely found in word final position. Verb and noun roots are typically consonant initial and vowel final, and verb roots take a monovocalic subject marker prefix in finite forms, and kind of in parallel to that, noun roots take a monovocalic class marker prefix. Valheitis arises at word boundaries in Ikbana in a variety of syntactic environments. As you see in this sentence, the deer cooked rice, we see underlying hiatus at both the subject verb and the verb object boundaries. And in both of those, hiatus resolution is optional. So you may or may not have the elision or at least partial reduction of one of the 2 vowels in each environment. However, some aspects of hiatus resolution seem more categorical. The vowel U almost always undergoes elision regardless of the boundary and regardless of its position, whether it is the first or the second vowel in a particular environment. So this raises the following questions. First, is Valheitis resolution in Ikbana sensitive to syntactic structure? And this will be what I'll be discussing with study 1. Next, is it sensitive to phonological properties such as vowel quality and tone? And this will be the focus of the second study. Finally, the third question I ask here is, to what extent is Valheitis resolution in Ikbana categorical or not categorical? So the data collected for this study was collected during controlled elicitation sessions that were conducted in Logba Alakpeti and Logba Tota, 2 of the 7 Ikbana townships in the Volta region of Ghana, in the summer of 2019. The data I'm discussing comes from 1 male speaker, 65-year-old speaker, from whom I collected 378 SVO sentences that were each translated from English and produced in 2 ways. So the speakers were asked to produce the sentences first carefully with no Valheitis resolution, like it is the case here. I hope you can hear this.
Agbe ota iti.
And then the speakers were asked to produce the same sentences casually, like it is the case here,
Agbe otete.
with Valheitis resolution. So altogether, I collected 641 tokens of underlying Valheitis at word boundaries, which is 1 to 2 per sentence. The reason why there aren't exactly 2 instances per sentence is that in certain cases, at the subject verb boundary, the the verb initial segment was a nasal and not a vowel. So these sentences were designed to get a full range of vowel contrasts and tonal contrasts at each word boundary. And although some combinations are not represented due to morphophonological restrictions. So let's move on to the first study. So here I'm focusing on the effect of syntactic structure on Valheitis resolution. So for this particular study, I'm analyzing 338 tokens, both at the subject verb and verb object boundaries, where the first vowel can be any one of the 7 phonemic vowels in the language, and the second vowel is a back mid vowel. And the reason for that is that those 2 phonemic vowels are the only 2 that are found at the same frequency at both boundaries in V2 position. Altogether, 14 V1 plus V2 combinations are represented at comparable rates at both boundaries. So first, there are some phonetic evidence for syntactic effects on Valheitis resolution. So duration measurements at subject verb and verb object boundaries show essentially longer durations at the subject verb boundary than at the verb object boundary. So here is the careful production for this sentence.
Ando ota adi.
And here's the casual production.
Ando tadi.
So when I talk about duration measurements at SV and VO boundaries, what I mean is measuring the duration between the end of the preceding consonant and the beginning of the following consonant in order to single out this Valheitis environment in the surface production. So I should make clear here that the casual production is the one being represented here. And the careful production is used for essentially as the underlying form. So V1 plus V2 durations show significant differences at the subject verb and verb object boundaries. And this suggests that the two boundaries are associated with different processes in the phonology. There's also phonological evidence for syntactic effects on Valheitis resolution in ICPANA. So as I mentioned at the beginning of the talk, different resolution strategies are available in ICPANA. And as it turns out, heterosyllabification is much more commonly found at the subject verb boundary, while elision is more commonly found at the verb object boundary. So here again, here's the careful production for this sentence.
Undu onu olo.
And here's the casual production.
Undu onolo.
Right, so while the vowel U at the verb object boundary is elided, both vowels U and O surface at the subject verb boundary. So here's the distribution of resolution strategies at the subject verb and verb object boundaries. And essentially what we see here is that as shown in the example, heterosyllabification is much more commonly found at the subject verb boundary, along with assimilation. So what I mean by assimilation is when either V1 or V2 takes the properties of the other vowel. And at the verb object boundary, it is elision and also coalescence and glide in only a few examples that surface more commonly. So altogether, the subject verb and verb object Heitis environments show significant differences in terms of duration, and also Heitis resolution strategies are selected at different rates at both boundaries. Valheitis resolution appears to be sensitive to syntactic structure, and the data suggests the presence of possibly an additional prosodic boundary at the subject verb word boundary, in line with previous research on syntactic prosody mapping. The second study focuses on the phonological effects on Valheitis resolution. So here, the data consists of 370 tokens, all at the verb object boundary with 42 possible vowel combinations. Only the vowel E is not found as V as the second vowel in the data, and this is due to morphological restrictions. And there are also 6 possible tone combinations with, again, more restrictions on the second tone, as class markers on nouns cannot surface with a high tone associated with them. So I ran 2 logistic regression models here. The first one predicting the vowel Valheitis resolution strategy with elision being the predicted factor versus other strategies. And here, what appears is that it is the interaction of V1 and V2 that closely predicts the use of elision instead of versus other strategies. The combination or interaction of tones 1 and 2 was not so significant, and V1 alone, V2 alone, tone 1 alone, and tone 2 alone were insignificant. So the second regression model focuses on predicting whether the first vowel or the second vowel was elided in instances of elision. And so here, again, it is the interaction of V1 and V2 that essentially predicted whether V1 or V2 was elided, and not so much the interaction of the two tones or any of those taken without interaction. So as far as tone, Valheitis resolution in ICPANA does not appear to be sensitive to tone or tonal interactions. And although underlying tones may be affected by Valheitis resolution, they do not contribute to its conditioning. For vowel quality, the story is different. The identity of a single vowel does not determine which strategy is used. However, it's the combination of the two vowels in a context of hiatus that is strongly correlated with the selection of a particular resolution strategy. And with strategies affecting one of the two vowels, the combination of the two vowels involved is also strongly correlated with determining which vowel is affected. So for the theoretical account for these observations, I'll be using Cophanology Theory. So Cophanology Theory is a constraint-based phonological approach in which each morphosyntactic context in a language is potentially associated with a different constraint ranking. This captures different types of conditioning, such as morphosyntactic or phonological. There are, of course, other possible approaches to this type of data, such as match theory and other prosodic approaches, and also approaches such as index constraint theory. So as a disclaimer here, why am I using Cophanology Theory? So in a more extensive version of this work, I'm using a prosodic approach to the data that I'm discussing here. However, crucially, the account becomes much more complex in more diverse syntactic constructions. And therefore, for the purpose of this talk, for expository purposes, I'll be using Cophanology Theory, which can handle the variation across constructions that we see in the data. And in order to deal with the variation found in the data, I'm using a Maxent harmonic grammar model in which constraints are weighted instead of being ranked. And this allows to account for variation in outputs with one same corresponding input. And constraint weights here are computed based on data observations. So here are the definitions for the different constraints. I'll be going over these pretty quickly. So star VV penalizes heterosyllabification. Star CG penalizes glide formation. And as far as faithfulness constraints, I'm using, in addition to dep and max, the following constraints with uniformity, which penalizes coalescence, star glide minus round, which bans glide formation where the first vowel is a non-round vowel, and the minus high counterpart, which bans glide formation where the first vowel is a non-high vowel. I'm also using positional faithfulness constraints with max word initial and ident vowel word initial, and lexical faithfulness constraints such as max lexical, which says don't elide a vowel that belongs to a lexical root, and the ident vowel counterpart, which bans V1 assimilation. So here are the constraint weights at the subject, verb, and verb object boundaries. And I'm happy to come back to those later. But essentially and crucially, at the subject verb boundary, start, glide, minus, high, and also start, oo are appear to be insignificant or inactive, while at the verb object boundary, it is start, consonant, glide that appears to be inactive. Here are example tableaus for the subject verb boundary for the two examples, example sentences here. And the takeaway here is that this maxent model correctly predicts the categorical absence of coalescence that is found in the subject verb data, and also the amount of variation that is observed in the data is correctly predicted. As for the verb object boundary, here are more tableaus that, again, I'm happy to come back to later. And here again, the maxent model correctly predicts the categorical absence of assimilation that is found in the data, and the amount of variation that is observed in the data is correctly predicted. As a summary, the proposed maxent model correctly predicts the categorical absence of coalescence in the subject verb data and the absence of assimilation in the verb object data. It also correctly predicts the amount of variation that is found at both boundaries, and subject verb and verb object boundaries are the locus of, in this account, distinct cophanologies with their own remarkably different constraint weights, sorry. Depth is unviolated across the data, and this translates the observation that Valheitis resolution is never resolved by way of consonant epenthesis. Here are the theoretical implications. Valheitis resolution is a multiply conditioned and non-categorical phonological alternation where the attested patterns are the result of a combination of categorical and variable conditioning factors, both in the syntax and in the phonology. The data suggests the need for multiple grammars or indexing or distinct prosodic boundary types in order to capture these phonological alternations. And this requirement is modeled here with cophanologies. As far as typological implications, it has been argued that either only faithfulness constraints or markedness constraints can be re-ranked, reordered, or indexed across the language. And this analysis supports the latter, with only markedness constraints showing significant reversals in relative weights. And the data also shows that overall nouns resist elision and glide formation more than verbs do. And this suggests that Ikpana nouns have phonological privilege over verbs. And finally, the methodological implications are the following. Phonetic methodologies can shed light on aspects of the syntax-phonology interface and on syntactically conditioned phonological alternations. Additionally, linguistic fieldwork can greatly benefit from and contribute to acoustic experimental research. This project shows that acoustic research methodologies are adaptable to field settings, and also acoustically, this is an instance of acoustically informed description and analysis of the sound system of an understudied language. Thank you.
Oops. Thank you so much. We have a few minutes for questions. Okay, and let me go over. We have Sammy's question from before, so let's just. So Betty, were there any other things that you wanted to tell us a little bit more about? But in light of some of the time issues, we always end up curtailing some of our comments. Did you have any other things that you would have liked to have told us a little bit more about?
Sure. So let me share my slides again. Right, so since I have a little bit of extra time, I wanted to come back to the two tableaus that I didn't really have time to go over in depth and discussing here. So I want to make clear here that in this version of the work, I'm focusing on the data from one single speaker, and in that speaker's productions, there are no observed, for instance, V2 elision and V2 assimilation at the subject-verb boundary. And this is something that actually the model predicts that we would find some of, at least at a very low frequency. And I'm actually looking forward to looking at data from more speakers, which I do have partially available, and see whether those predictions that we see here hold when considering data from multiple speakers. Same at the verb-object boundary with heterosyllabification, glide formation, and also coalescence that are predicted to surface at pretty low frequencies, but are still predicted to surface some. Was there any question?
So any other thoughts or reactions or even suggestions for moving forward? Oh, we've got some more coming in. So we have something from Anya Hokoboom. So, or sorry if I'm butchering names here. Can I ask you where you found glide formation? Is it after the E sound?
Not necessarily. It's it could be after E, it could be it could be when the first vowel was any of the vowels essentially, except for A. Yeah, but any non-low vowel could in first position in the hiatus environment could potentially surface as a glide.
Super. Katie Russell asks or says, hi Bertie, so thank you for this great presentation. You mentioned that there has been a lot of influence from UA recently. Do you think that influence can affect the vowel hiatus resolution strategies at all? And I really apologize for butchering the language names. So you can tell that I spend a lot of time with Indo-European languages.
So that's a very good question. Thank you, Katie. Actually, that's something I'm very interested in, and I'm hoping that in the long run, I'll be able to get to. I am actually not sure I know anything about that at this point. And one of the reasons for that is that EVE is not, doesn't have as much underlying vowel hiatus. Typically, both nouns and verbs are consonant initial. And so even if I was looking at data, I would have to think very carefully of where I could find Valheitis underlyingly in EVE data. And also, I haven't really got to looking at EVE data just yet.
Perfect. And then we have a question from Jessica Holtz, who asks, thank you for the great presentation. Have you been able to investigate instances of hiatus where elision might result in homophony with another phrase, creating confusion? And if so, have you found that hiatus resolution is blocked in these circumstances, or if a different resolution strategy is used or something like that? Or if a different phrase is preferred altogether in these instances?
That's a very good question and suggestion. Thank you, Jessica. That's something I haven't got to at all. But I don't think I have collected this kind of data at all, but that's definitely something to keep in mind, and stay tuned for later versions of this work.
Awesome. And then the last question that we have from Maddie Gilbert, we have a question. Do you have any sense the Valheitis resolution might differ in younger speakers?
So this is something I predict to be the case based on the data I have collected. I do not have an analysis ready just yet, but it seems to be the case that younger speakers behave differently in the way they resolve hiatus, and also speakers of other varieties. So there are multiple varieties of Ikpana, and the speaker I worked with for on the data that I presented here speaks the Tota variety, while other speakers speak the Alakpeti variety, which seems to be actually closer to Eve, and I'm looking forward to being able to talk about that more. So again, stay tuned for later versions.
Super. Okay. I think we've answered the questions that we've had so far, and any other comments or questions? And in fact, you bring up an interesting point too, because you said that there are about 7,000 speakers left. Okay,
Yeah.
which is, wow, talk about a lot of work to be done as quickly as possible. But and you said that there are multiple varieties then. So, but how many speakers are there right now in the various varieties?
So I would say, so the Alakpeti variety is definitely the variety that has the most speakers. And this is because the Alakpeti town is on the main road and has is much larger than the other Akpanawo townships. And on the other hand, the reason why I focused on Tota and Alakpeti varieties is that Tota is the smallest Akpanawo village, and so as such, it has a much smaller number of speakers.
Excellent, thank you. Well, that is our time. There is a comment for you to read from Jessica Holtz in there, and thank you so much for an excellent talk. And for those who are still there, to give a little round of applause for Betty and also for our speakers in our panel. What an excellent set of talks. So thank you so much, and enjoy the rest of your sessions, everyone. Okay, bye.
Thank you.
Thanks, everyone. Take care.